Hello viewers. This video is going to serve as a supplement to the Introduction to Programming post as found on my personal website. My hope is that by watching this video, you should be able to have a better understanding of the topics that I've covered in this post. There are a handful, and I've provided examples for each of them. So without further ado, let's get started with the first example. Okay, so here we are in our Java compiler. This is a compiler app called Eclipse. And all I'm going to do is take the code from my post and paste it right here. Now that the code is here and we haven't returned any errors, which are shown by red lines as seen in Microsoft Word, we can go ahead and click this run button right here to produce the result of this code, as shown by the number 5 in our console down here. And just in case you are lost, I want to take some time to go over what's going on here and why we got a result of 5. So all that's happened here is, if we start with this first line, we have an integer named x, and we've assigned a value of 5 to that integer named x. We then have a print statement right here, and we decided to print the value of x to our console. If you have any questions about any of the symbols that I've used or some of the syntax that you can see here, you can find more information in the programming logic section, where I've outlined just 5 points that are worth considering, or things that you need to know when looking at programming code. And this can be found on my personal website. The easiest way to get there is through this URL. I'll also post a link to this in the YouTube description. So now with the first example out of the way, we'll be moving on to mathematical expression. The example for mathematical expressions that we'll be taking a look at is this 3-line code. And now all I'm doing is copying the code from my post and pasting it into the Java compiler. With the code now existing within our compiler and the lack of errors, we can go ahead and run our code, and we can see that the result that gets produced is 36. Okay, so as you can see here, I have my post open and my Java compiler open, and now I just want to take some time to go through each of the lines of code as shown by these numbers and explain how and why things are happening here. Just like with our first example, in this example we start off with a declaration statement. We have an integer named x who's been assigned a value of 7, and here's the written description for that. And now we move on to the second line, where x has a new value being assigned to it. To determine the value of x following this expression right here, we have to think about how things work in algebra. So when taking algebra, you may have come across this acronym, PEMDAS, and this is just an acronym that's used to guide people along the path of operator precedence. What we know about operator precedence is that, at least in this specific example of PEMDAS, we have parentheses, exponents, multiplication, division, and addition and subtraction. So following through this tiered system of prioritizing earlier mentioned terms, we have parentheses which are included here, and we want to solve whatever is within the parentheses first before evaluating the rest of this expression. So what that does is takes the value of x and increases it by 5. And we know that at this point, x has been declared to have a value of 7, so we're taking 7 and increasing it by 5. That returns a value of 12, as you can see right here. Now that we know that x plus 5 is equal to 12, we can go ahead and remove these parentheses because there's nothing else to evaluate. And now that that's the case, we're left with 3 times 12. And that returns a value of 36. Okay, so the last piece of information that you need to consider is that all of this evaluated to 36, and if we're looking past the expression that's still here, we have x and equal sign 36 and a semicolon. So following through with the format similar to this, we're taking x and assigning it the value of 36. And by doing that, the value of x is now 36, regardless of whatever it was assigned before. So in essence, what I'm saying is x is now 36, as shown by what you can see here in the console, and is no longer 7, as it was previously declared to be so. Okay, so now we move on to our next example, which involves the 3 loops. So, like with the other examples, I'll just be copying what I have there and putting it into the Eclipse Java compiler. Now we can see we have our code and it's free of error. Oh, wait a minute. It's not free of errors. We've got these red lines, as you can see here. These are the lines that I had mentioned before, and they're similar to what you can see in Microsoft Word when, I don't know, you may misspell something or you're missing punctuation. All the compiler is doing is letting you know that there's something wrong with this. The cool thing about the Eclipse Java compiler is that if you hover over it, the error that you're getting, you can see an explanation which says x cannot be resolved to a variable. What this means is that I have never declared the variable named x, so how could I assign a variable to x when it doesn't exist yet? To remedy this, all you need to do is declare the variable x before the statement that says it's going to get assigned. So in this case, we'll just have it right above of it. Now that we have this, x has properly been declared, and when it comes time to, we can go ahead and assign values of x based off of its previous value of 0 and increasing that by 1 wherever the for loop allows for that to happen. But before we go on further with the result, I want to explain how the for loop works. So, in order for a for loop to work, we have to consider the 3 sections that it has. Every section is separated by a semicolon. So this is the first section, this is the second, and this is the third and final section. So what the for loop allows you to do is declare at least one variable and assign a value to it, or all of them. Consider a statement and evaluate whether that statement is true or false, and finally do something with at least one of your variables. A loop will only run under this condition. If this evaluates to be true, the loop will run, and will run as long as if this remains true. So we know that at this current time, I has a value of 0. So we can substitute I for 0 and say that 0 is less than 7. Is that true? Well, yes it is. We know that 0 is a smaller number than 7 is, so the for loop will run, and will continue to run until the value of I is no longer less than 7. Without further ado, we're going to see how the for loop behaves. For the purpose of this demonstration, I got rid of the old code that you saw a couple seconds back, and I made it like this so things were a bit more clear when taking a look at the result in the console, which has now been returned to be a value of 7. So now I'm going to walk you through the code. So again, we've seen this statement a bunch of times, and all this is we're creating an integer named x and set its value to 0. Then we have a for loop that has a bunch of information in it, and before it runs, we create a variable named I and set its value to 0, and evaluate whether or not this statement is true, 0 being less than 7, and if the loop runs and completes a run, we'll increase the value of I by 1. So with all of that being said, we know that 0 is less than 7, so everything within these squiggly brackets is going to run. And the only code located within the for loop is this right here. And it just says that we take the current value of x and increase it by 1 and set that value to x. So if we're running this loop for the first time, we're taking a look at the current value of x, which is 0 as stated up here, and increasing it by 1. So 0 plus 1 is 1, and the value of x is now 1. We have now reached the end of our code because we've finished this line, and here we are hitting this squiggly bracket. So now that the code has completed its first run, I is increased by 1. As a consequence of this, we're now taking a look at if 1 is less than 7. 1 is less than 7, so the loop runs again. And here we are looking at this piece of code again, where we take a look at the current value of x and increase it by 1. So we know that the current value of x is no longer 0, because the first time this for loop ran, we ended up increasing 0 by 1. So now that we're running this loop a second time, we know that the value of x is now 1. And what this code is saying is we just take the current value of x, which we know is 1, and increase its value by 1. So by extension, that means 1 plus 1, which is 2, is now being assigned to the value of x. At this point, we've hit the end of the for loop, and now I is increased by 1. And here we have 2 being less than 7, and evaluating if that statement is true or false. This repetitive process will continue until I is a value that is no longer less than 7. Eventually, when that happens, we leave these squiggly brackets and continue further down with our line of code. I've added a print statement here to show us the value of x after the for loop is done. We can see that that value is 7. If you feel lost at any point during this video, I would again tell you to check out my Introduction to Programming post that you can find on my personal website. I've tried to be as detailed as possible in explaining everything that I've presented, and this is definitely a great way to supplement what you can see in the video with a bit more of an in-depth, or I guess strictly written explanation for everything. So definitely check that out. And now with those examples out of the way, we move on to our final section, the if statement. The if statement is a conditional statement, and it's pretty similar to how a for loop works. A for loop and if statement both contain conditional statements, which are expressions contained within parentheses, as you can see here, and as is presented right here in my previous example. And just to recap, a conditional statement considers an argument, or in this case an expression within an argument, and will evaluate if this expression returns a true or false value. After the value is determined, if whatever is within the argument evaluates to a true value, the if statement will run in this case. And if it returns a false value, the if statement in this case will not run. Alright, so now we're back in Eclipse, and I've taken the code from my post and put it in the compiler. And now, just to walk you guys through everything, we're starting off with the first line of our code, which is a declaration statement yet again, where we have an integer named x who's assigned a value of 5. And now our next line is the if statement, which contains the run condition that considers if the current value of x is equal to 5. Since we just did this, we know that x has been assigned a value of 5, and when you're comparing 5 against 5 for equality, we can say that 5 is equal to 5. So this will return a true value because 5 is equal to 5. And by extension, the code within the squiggly brackets for this if statement will run. So now, this means we're substituting the current value of x with 80. And this print statement right here will show us that in the console, right here. X is now 80 at the end of all of this code. Alright, well, that concludes my video supplement to the Introduction to Programming post as found on my website. I want to give a big thank you, a sincere thank you to you, my viewers, who have taken the time to watch segments of this video or the entirety of this video. I really do think it's great that you've taken the time to do this, because I honestly see a lot of value in programming, and I hope that you can too. If you have any questions or would like to leave a suggestion, you can visit my contact page found on my personal website, and you can go ahead and leave some information and type your comment here.